Hello, everybody. We are live. I'm Justin Meyer, creator of CanJS, JavaScript MVC, jQuery++, and soon to be done.js. And with me, as always, is Alexis Abril, Bitovi's main JavaScript trainer. This week, we are going to talk about can.Map and can.List, two of CanJS's observables. CanJS has direct observables, which means you can directly observe them instead of kind of side effect, like dirty checking, which is what Angular does, where some other system is running and checking if objects have changes. Instead, with CanJS, you create objects that when you set them or make changes to them, it produces events, and you can listen to those events. So we are going to talk about can.Map, which observes objects, and can.List, which observes arrays. And Alexis has prepared a little training where you kind of walk through the different APIs, and there's a little assertion test, and he'll be going through that. So without further ado, I'm going to share my screen, and we can get started. Oh, and as always, if you have any questions or comments, please feel free to add them to the JS training link, to the JS training getter, which I'll show in a second. And there's already a question that someone had from our training that we did for Front-End Masters that we will answer at the end of the talk. So let me actually show the training. So if you go to gitter.im, Bitovi/JS training, at the end of every one of these, any questions that are put in here, we will answer. And they can be anything related to JavaScript or front-end programming. We can also give relationship advice too, but we're not qualified for that. So with that in mind, I'm going to try to start this presentation. There it goes. So CanJS's observables are here to power the observer pattern. And CanJS observables, can.Map and can.List, and also can.Compute is another form of observable that we'll talk about later. These are really useful independent of DOM-based JavaScript programming, which is the nice thing about CanJS. Although it's not really used outside of that. If in Node I wanted a observable, I could use can.Map and can.List. Because observer pattern, especially with user interface programming, is very common. And the observer pattern, essentially you have observables, and observers can listen to them when they change. So you might have an observable like a can.Map, and you might have different parts of your code base listen to when that map changes and update themselves. So the first observable in CanJS is can.Map, and you can create it like this. And then if you want to, you pass it an object, and then we could label it person. So we create a new map, and we're calling it person with a name property that is Josh. I can read the name property through this attribute method. I can also, and this is what makes it observable, I can listen to when person's name property changes. And if I change the person name property from Josh to Justin, this event handler will be called back with the new value, which is now Justin, and the old value, which was Josh. So there's also can.List. This allows you to observe arrays. And here you can get each item in the array through the attr method. Again, you pass it a number, and it will give you that item, that indexed item in the array or in the list. And you can also listen to when items, instead of named properties, you wouldn't really want to listen to a 0 property, although I think you might be able to. I think you can actually. Typically, you don't want to do that, though. You want to listen to when items are added or removed from an array. And here, hobbies, you can bind to when an item is added to hobbies. And so we get called with the items that were added and where they were added at, which index. So if I were to add 2 new hobbies with the push method, and it should be noted that hobbies or can.List support all the same kind of methods that you're used to on arrays. So you can treat them pretty much the same, except you always read them a little bit differently. And but to modify an array, you can use the same methods you're used to. And when you add items to this array, items will have, it'll tell you that you added these 2 items at the index 1 position. So finally, there's can.Compute, which you've kind of done an introduction with previously, but essentially can.Compute lets you either observe single values. So here I just want to observe 30, a single reference to a value. So this compute references the value 30. I can read the compute, get back 30. I can listen to when this compute changes its value, and I can set the value, and a change event will fire on this compute. But computes also can derive other values, and we're not going to really talk about this much today, but it is the third the third wheel or of the CanJS observables, but it's really heavily used internally by CanJS. Here I can create a compute, an info compute that represents an observable person's name, their age as another compute, and their hobbies. So here I can read info, I can listen to when info changes, and if I change any of the dependent observables in this compute, the info's change event will fire. But we're not going to focus on can.Compute. We're going to really focus on the can.List and can.Map. And we'll talk about how it can be really useful in decoupling widgets. But first, at the risk of repeating myself ad nauseum, which we've talked about this section of slides a bunch of times, but I think it's really important to stress the usefulness of observables. Let's talk about how apps are written without observables and contrast that with apps that are written with observables. So here, and if you've seen this already, we talk about this, you can probably skip ahead 5-6 minutes and not really miss anything, but anybody who's watching new, this is important. So let's say I had a very basic app where it allowed me to search different social media, websites for something. And when I hit search, it would show me the results, and also it would save my search in a search history. And then if I clicked search history, it would show me the results and update the search page. A lot of times the way people write this when they're beginners is they say, hey, I'm going to build 3 different widgets. I'm going to build a search widget, I'm going to build a search history widget, and a kind of results widget. And what they do is say, okay, I'm going to listen when this search form is submitted, and I'm going to call out to my history and say, hey, add some new search data, and I'm going to call up to my search results and say, update yourself with this new search data. And what that does is makes it so that this search widget knows and has a dependency really on the history widget and the results widget. So I'm drawing those dependencies here. Similarly, in search history, if when someone clicked a search history term, they might then say, hey, search form, add some new search data or update yourself with search data, and your results, update yourself with search data. So that might do something like this. Right? That creates a dependency of the search history with the search and of the search history on the results, because then search history needs to know about those things. Now, this kind of everything kind of depends on everything else isn't so bad for a small application like this, but it really gets nasty if you have something else with a lot more widgets that need to kind of intercommunicate. So let's look at all the widgets that deal with kind of what data is being shown on the page. I'm kind of highlighting them. The graph, obviously, this little subgraph, the amount of the graph that you've selected here, where you've scrolled to, right? That changes everything. So think about it. If I were to change any of these, the zoom, the period of the graph, or the range of the graph, I would have to update all of these other widgets, right? So that they would reflect that change. And then if I were to widen this out a little bit, I would have to change all the other ones. And if I were to change the scroll bar position on the bottom, I'd have to change all of these, and so forth. And you can see how this kind of becomes a really big mess where everything needs to talk to everything else. This is the handshake problem, right? How many vertices, right? It is vertice, right? I can't remember my graph stuff. Whereas vertices is edges. How many edges?
Yep.
Yeah. How many edges are there? Basically, how many handshakes are there if every single person in a room has to handshake everybody else? And this scales with n squared, right? So it's a little bit, if you have 2 people, it's approximately, well, it's 1, but you could think of it as 2 squared. 4, if you have 4 people, it's 4 times 4, right? If you have 8 people, it's 8 times 8. If you have 10 people, it's 10 times 10. It scales faster than linear, which is bad, really bad for humans to comprehend. So what professional programmers do, or I think anybody who's really done this, like this is one of the most important first steps that we do when we're building any JavaScript application, is to identify what are your observables. What are the values that, what you do is you put an observable in the center of this, and then everything listens or changes that observable. This way, Zoom doesn't actually need to know about the graph, and the graph doesn't need to know about the zoom, and everything doesn't need to know about anything other than this one observable that they all know about. So yeah, the first thing we do is, what is the shape of that observable, right? We always try to figure out, what does that state look like? Oh, I kind of forgot to mention this part. So what happens is, with observable is when I click 6 months here, that's going to change the state of the observable, and then that notifies everything else to change. So yeah, we set about, what does this observable look like? We always try to figure out, what is the real root state of the application, right? A beginner might say like, well, it's the period, right? It's 6 months, 3 months, we want that. But really, your start date and end date can provide your period. So what I'm always trying to do is figure out, like, what is, instead of saying, the range or time, it's 6 months, I'm gonna have some property called period, and it'll be 6 months or a year or whatnot. Instead, I'm always trying to figure out what is the more, the root properties that represent the state, like the lowest level thing that I could possibly have. And in this case, it would be like a start time and an end time. Because if you want to figure out how far you've zoomed, you can always subtract these 2 numbers and get it. So trying to suss this out is really, really an important skill and very useful. And the first thing you should do when you're building any application. And what we do with CanJS is we say, okay, this is a can.Map, right? Sometimes this will be in the route, sometimes this will be in a view model of something, but there's always a can.Map that is essentially housing these properties, and then the rest of the application is listening to them and updating itself. And sometimes we'll pass around this can.Map so other widgets can listen to it, this state. So if we were to look at this application, what would be the core behavior, right? What's the core state? What does it look like? Well, we can see we kind of have a search. What we're currently searching with its different media types is really the state, right? So every time your new search term changes, the search history should update itself, or the search history should change what is currently being searched, and this should update, and obviously this should update anytime it changes. So if I were to define what the search looks like, it might be the query and the types. And anytime any of this changes, you update the page or the search history. So now let's talk about can.Map and its API that lets you do all of this stuff. So to create a can.Map, you do new can.Map. It's pretty straightforward, and you pass it you don't have to pass it anything if you don't want your object to start with properties, but if you do want it to start with properties, you pass it the properties you want it to have. So name is Alexis, and you get back an observable map. And then you can read property values by calling this attr method. If you give it a single property name, you get back the value of that property. And if you call attr without any arguments, you get an object back that is essentially almost like a serialized representation, a plain JavaScript representation of your observable data at that point it was read. So setting property values. If you want to change the values on an observable, you can call this observable.attr method with the property you want to change and the new value at that property. And you can also pass it a list of properties or an object of properties and values that you want to change. Now, the important thing to notice right here, and so you can see here, I've got an object with name Alexis. I've changed the name property to Justin, and then I'm calling observable.attr with an object with an age property that's 30. Notice that Justin, the name property, wasn't removed. What this does is it just adds any properties found here. It's not going to remove properties that aren't in this list to begin with. So I can actually change that if I pass true as the second, or if I pass an object followed by a Boolean true. What that does is it's not only going to add or change an age property, any other properties that aren't listed here are going to be removed. If you want to remove properties yourself, you can always call observe.removeAttr. So if I called at the end of this, and my observable had an age property, and I called observable.removeAttr age, and then got all the properties, well, I get back an empty object at this point. So observables aren't really useful. Well, in reality, CanJS with the define plugin, its observables would be useful even if you couldn't actually observe them, because it has getter setters and things like that. But observables primarily are useful because you can observe them. So CanJS allows you to listen to when any property is changed on an observable, and this also does that recursively. So you can also listen to when any of your child observables are changed as well. This is kind of frowned upon now, but it's useful for debugging, but it's kind of frowned upon now because it does slow CanJS down quite a bit because it binds on everything essentially, when it really should only be, you typically only want to listen to what you want to listen to. Anyways, so I can listen to a change event though, if I wanted, and on my observable, and this will get called back anytime anything changes, and it'll tell you which attribute changed, how it was changed, whether the property was added, removed, or set. What set means is that the value already existed, but you changed it. And then finally with the new value and old value at that place. So again, you really shouldn't listen to the change event though. What you really should listen to, if you're going to listen manually at all, is the named events. So what I can do is say, I want to listen to when the name property of this observable changes. You might have noticed you probably shouldn't have any can.Map. You can't have a property called change. Don't do that. Things go bad. But other property names are pretty much valid. So if I had a name property, I could listen to when that changes its value, and I would get back when its new value and old value whenever it changes. So there's some helpers that CanJS comes with to make certain things a little bit easier. So if I had an observable, here I created my observable, I can call .each, and this loops through every property on the observable. So it goes through, it'll give you every property name and every value at the property. There's a serialize method that gives you, this is very much like calling attr, but the default behavior is really actually identical to of attr. If you call attr without arguments, you get essentially a object representation, a plain JavaScript object representation of your observable. However, serialize is useful when you're using the define plugin, because sometimes you want, like, let's say your observable, I had a date property in here and I actually passed it a JavaScript date. Well, maybe when you call serialize on your observable, you want that observable date to be converted to a string or to a number that represents that date time. You can overwrite serialize with plain can.Map, or using the define plugin, you can easily make it so that when that date type, when you actually call serialize, you're not going to get a date instance back. You're going to get a string or a number. So this doesn't do much at first, but is like kind of a placeholder function for you to fill out or add more complexity to. There's also an observe.compute function where you pass it a property. And what that does is it's going to give you back a compute that is two-way bound to the property name that you passed in here. So you can see if I have this observable here and I say observable.compute first, that's going to give me a compute that when read gives me whatever is here, whatever the first property is of this map. And if I call the C compute with a new value, it'll actually change the observable's first property as well. So this compute is two-way bound to its observable. This can be useful if you don't want to pass an entire object to something. Instead, you want to pass a compute. Well, you can do that here. So can.Map keys. This basically gives you all the key names on an observable. It's kind of like each, but it doesn't have to read all of the values. It's essentially just giving you all of the keys. So can.Map inherits from can.Construct, and we didn't really give a talk on can.Construct, but can.Construct is a low-level helper to make constructor functions in CanJS, make that a little bit easier. So you can extend can.Map into your own types of can.Maps. So this is a special person can.Map type that works just like can.Map, except it has these maps now have a full name function on them added to their prototype. So here you can see I can create a new person, and I can create a new person, and then I can call a full name function on that person. So that's pretty straightforward. You can also create, with the define plugin now, you can create custom attributes that are kind of like, I would almost call them like a virtual, I should probably call them like virtual attributes. In this case, there is no, whoops, this slide is bad. Hold on one second. I think I got carried away with trying to make it small and forgot to include all of the correct code. I wanted to fit on the page. Hold on, let me fix this. There you go. All right. I think I'm gonna have to put that on this slide too. Just the define part. It's getting a little big, but it's all right. So here, notice we have a previous slide. Here you can see we created a full name function. But let's say I wanted you to be, I wanted who is ever using these person constructors to be able to call me.at full name, right? I want a full name so it looks like a property, not a function. So you can define these kind of virtual properties with the define plugin, which extends can.Map to allow these kind of things. Or I could say I want to define full name, the full name attribute. And I want to say it's a getter, it's a virtual getter that when you read it is going to essentially get the first and last properties. So here, I can actually create a new instance of person and call me.at full name. I don't have to call it as a function. And you can also bind to full name. The same way you can bind to first and last, which you cannot bind to full name here unless you create it into a compute yourself. So this is really nice for creating observable properties that are really composites of other values. And the define plugin actually allows you to go as setters, allows you to do asynchronous getters and asynchronous setters, and there's just a tremendous amount of power in the define plugin. So you can also provide default values with can.Map. When you extend it, you can just, any kind of primitive type that you put on the prototype here, those will get set as default values. So here I can create a person without any first or last name, and you'll notice here when I call full name, it gives me a value. Now, this is kind of an older way of doing it. In reality, you can also use the define plugin to define the default value for first and last, which is probably the better way going forward. Probably the, I don't think 3.0 is going to drop doing it directly on the prototype, but I could see a 4.0 maybe doing that. Okay, so there's can.Map, and now we're going to pass it off to Alexis, who's going to walk through a part of his exercise that deals with can.Map.
Yes, sir. So let me share something with everybody. Actually, let me share the screened version of a really, really straightforward JS bin that we got. So here, this should work. Drop this in the Gitter chat. Again, if you're just joining us, our Gitter chat is gitter.im/bitovi/js-training. I hope I got that URL right. That was off the top of my head. Okay. Actually, let me link you a second time. Okay. So the JS bin I just dropped in the Gitter chat is if you would like to complete these exercises on your own. There's some basic map and list exercises. I'm about to go through the map exercises. If you would like to follow along as I do this live, check out that second link. That'll be the stream there. Let me share my screen so you guys can, if you're not in the Gitter chat, you can just see my screen. That'll work too. All right. So I'm not going to go through the full map API. Map is really, really powerful. But I'm going to go through some of the basics. Let me get rid of this here. There we go. Well, let me show this as well. I'm going to go through listing for changes, setting some attributes. Remember, one of the most important things about maps is you can know when something is modified. So if you have a basic object, let me type this on top.
Alexis, you might make your font a little bit bigger.
Oh, okay. How's that?
That's better.
All right. You can also click the stream link. We'll show you this any way you want it to. If you had a basic object, so ignore the everything.
Like your font just went back to being smaller? Or is this the bigger still?
This is bigger.
I'll give it one more plus up then. There we go. That's better.
Okay. I do have a very high resolution screen, so if it's trouble for anybody watching at home, be sure to check out the Gitter stream chat. That is going to be whatever resolution you choose. But let's say we had a simple object here. We have a person object, and if we wanted to give person a name equals Justin, this is very straightforward. We can see we're setting a property on the object to this string. Maybe we're going to do something with it later. We'll put it into the DOM. We'll set an input value. Who knows what we're going to do with it? The trick is having something do that automatically. Have something in the DOM respond, or have some other function respond. But to do that, we would need to know when name changes. Now you can do this, you can start to do this today with things like object.observe, but it's nice to have some kind of underlying library abstract all this out for you in an efficient way as possible. So in our case, we have a simple map with a name Justin. This is a property on an instance of our observable object. What we're going to do in this first exercise is we want to know when something on this object changes. And whenever that change occurs, we're going to put the new value in the DOM. There's some boilerplate DOM we have set up for you. This is just a div ID of name. We're going to assume that's in our HTML page. And whenever we have a change to person, we're going to put the new value in this div. So let's do step 1. If you don't want to see the answer, now is a great time to pause. It'll take me about maybe 10 minutes to get through all 3 of these exercises.
So Alexis, just to recap, you want to keep the DOM updated with person's name. So whenever person's name changes, the DOM will show that.
Exactly.
Awesome. You're building your own little version of live binding.
Pretty much. Right. This is all one way because we're not doing any input modification at the moment. But this is exactly this. If you're familiar with the term one-way live binding, this is a really, really simple way to do it. I
think live binding implies one way. Like when everybody says live binding, I think they mean one way.
Oh, really? Today it's been synonymous with two-way because everybody does it.
What?
Today I've found in the community it's synonymous with two-way.
Really?
Yeah.
Interesting.
When we're talking about one-way versus two-way, we're just talking about automatically sending information to the DOM and updating the DOM. Two-way would be in the inclusion, having the DOM have a change, updating some object behind the scenes. So if you change the value of an input, maybe you type in your username, behind the scenes, an object with a property of username is updated to reflect. That's two-way. But this is a very simple implementation. We're just using CanJS for the observable object, can.Map, and jQuery. That's all we're going to do for this. So the first thing we need to do is bind to person changes. Doesn't matter what we do with this, we just know we need to invoke a function when there's a change on person. So I'm going to say person.bind change. This is the part that we care about. And I'm going to invoke some function. This is all we need to do to listen for changes on an observable map. When something changes, some change occurs, we're going to invoke this function. From Justin's previous slides, we know this function gets a couple of arguments. We'll give you an event object. We'll give you the attribute that changed, how it changed. So in this case, if we're about to change the name of this object, the name of this person, attr would be name as a string. How could be set if the property didn't exist before. It could be change if the value has changed, if a change has occurred. It could be remove if you're removing the attributes.
It's not change. How will never be changed.
Oh, I'm sorry. It'll always be set in this case.
Add, set, or remove.
Add, set, or remove.
And remember, I just like to remind people, you shouldn't typically not bind on the change event anymore. There's really no reason ever.
Well, this is an intro to maps. They don't, I mean.
You could probably solve the same thing by binding on the name property.
That's the next exercise. So how is going to be how property is changed. And then you have the new value, the value that it's about to be set to, and the value that it previously was, the old value. So what we want for this exercise is when a value is changed, let me run this test so you can see it's failing at the moment. We have a nice little QUnit harness set up for us. And the assertion we care about is this first name is set assertion. What we're going to do is place the new value, which is this argument right here, val, into the text of this div that exists on the page. So I'm going to say text val. We're going to modify the DOM with whatever the new value is going to be set to. Then, if I just run this again, this is still going to fail because all we're doing is setting up the change. We're not actually doing anything yet. Let's change the person's name. This is where the attr function is really, really important. It's kind of our middleman for setting all this up. It's how we know something has changed and we can invoke any necessary events. I'm going to change the name of this person from Justin to Alexis. I believe that's what we're testing. Now, if I run this, we can see we have a nice green assertion here. What this is doing is it's changing internally. We have a name property that we keep. We're modifying that to Alexis and triggering any registered callback functions, anything we've bound to. So in this case, this function will be called. We'll look for an element with the ID of name and change its text to the new value. Now, Justin was completely correct. This is going to respond to anything on the person changing. So if you change the age property or the favorite color or maybe a hobbies property, anything else that changes will also modify, we'll also call this bound function, this handler. And that's maybe not what you want in terms of performance or just being specific. This is, if you have any new features or properties coming along down the road, this will keep getting called every single time. So the second exercise, we're going to bind to only a specific property on person. So we're going to listen for the age property. Now this doesn't exist right now. This is a new property we're going to add. So what we're going to do is same syntax as before, except we're going to listen for a single attribute, age. And whenever age is modified, added, or removed, we're going to call this function here. We will give you similar arguments, but we're just going to say event, val, and old, I believe. Is that correct, Justin? I did that off the top of my head. I don't think we pass a how here.
Yes, it's just the new value and the old value because you don't really care about how.
Right. Okay. So we have this callback, and what we're going to do is going to place the new value, the new age, into a div ID age. So these the div modifications, the DOM modifications are really just so we get used to using CanJS with some kind of DOM manipulation library, jQuery in this case, and you can see a little bit of a practical implication. So what we're going to do here is listen for any age-specific changes, modify the DOM to include their new value. Then we're going to say person.attr age. We're going to change the age to 32. And now, oops, did I?
It's because you're changing on the change event is fired when age is changed.
Oh, that's true. Very true. So here, and this is the problem we were just talking about. Here you would want to restrict. And this is what Justin was referring to in terms of you probably don't want to be using the change event. So here we'd have to do something special, like if adder is equal to name. There we go.
That's actually not why I was saying not to use the change event. It's the reason not to use change. Change is fine if you want, like, well, the change event is slow. I'll put it that way. If you care about the name property changing, or you then cared about the age property changing, or you cared about both changing when the name or age changed, you should almost always use a compute to kind of assemble those values yourself instead of manually listening to the change event. The reason is that the change event essentially is listening to any property change, which is expensive, and any child observables, it's also listening to when they change. So it's kind of like, you know how Firefox, if you started listening to mutation events, everything gets slow?
Yes.
It's kind of the same thing. Like once you start listening to change events, we set up all this event bubbling and things like that that can make things slower.
Sure, totally.
So that's to avoid change unless you really need it, basically.
Yeah. Very true, very true. A long way to say there's a lot of reasons not to use change. The audience at home doesn't know about computes too much yet, so we haven't spoken about that. But there is better ways to do all of this.
Yeah.
To do this specifically, I should say. This part's okay. So now we have handlers. We're listening for general, generic change events. We're listening for specific properties. You can also listen for the removal of a property. So here we have part 3 of this little exercise. We're going to create a new observable object. We're going to call it Bob. So let's start there. Var Bob is new can.Map. And we're going to give Bob a property called eats. And this is going to have a Boolean value true. Well, it doesn't need, it's arbitrary. So I'm just going to give him a value here. Eats true. What we want to do is listen for when Bob changes. We're going to listen for the old value. We're going to remove this eats property, but we want to see if we can get a handle to the old value. So, and I can do this a number of different ways. We can do eats, say function that val old. And what we're going to do is say, we're going to keep a reference in the DOM. We're just going to, let me start over that sentence. We're going to place the old value into this div, just so we can see what had been modified. And we want to remove this property from the from this object. So we're going to say bob.remove adder. And we have our nice 3 assertions. So if you're doing any kind of modification of an object within your application and you need to clean up some data before you send it back to the server or before you send it to the next function, whatever you happen to be doing with it, you can remove an attribute with remove adder. This is a little different than saying just flat out bob.eats equals undefined, which will dereference that property, but we're not going to know. There's nothing observing this that's going to be notified. So remember in Justin's diagram where you saw the little heart send out messages to all the widgets, letting them know that something had changed, adder and remove adder is going to be your mechanism for what sends out that notification. If you do any kind of like manual bypass, other widgets aren't going to be, or other observers aren't going to be aware of any change. So remove adder and adder are really, really important.
What's the difference? What if you had just done bob.attr eats undefined?
Bob.attr eats undefined? Oh, that's a good question. That wouldn't trigger, that would still trigger this. This would still work. This is probably a weak test for that. That would keep the pointer on the object, whereas remove adder would actually remove the attribute from the object. So let me write that out in a serialized version.
Key is really, yeah, it's kind of like when you use the delete operator.
Exactly, yeah. So right now, Bob serialized, let me comment at this. Bob serialized before we call remove adder is going to be something like this. Eats true. This is a simple object representation of Bob. Now, if Justin's suggestion was, what happens if we say this? Adder eats undefined. In this case, the object is going to change to this.
Does this mean like if Bob eats undefined, he has a very peculiar diet?
Yeah, maybe he's evolved like to some, you know, eats by osmosis or something.
Yeah.
Versus, and this is a little bit of a quirk, I guess, because if you're used to seeing delete versus something set undefined, although setting something to undefined is identical, because you can have pointers. As long as they're referenced, a pointer will exist and it'll still be undefined in JavaScript.
Wait, sorry, say that again?
As long as a pointer is you're holding a reference to it, it can be undefined. You can pass undefined around in JavaScript. Once you lose the reference and it's undefined, actually just once you lose the reference.
I'm not sure what you mean.
We were talking about just remove adder, like Bob at youth equals undefined.
Yeah.
Something like this. Because this is still a pointer on Bob, this actually will...
Well, let's call it the terminology we should use is property. I mean, there is a pointer, there's a property there, which has an area to point at things.
Yeah.
Right? But there's a property. So there's still a Bob, in that case, in JavaScript, there's still a bob.eats property if you're setting a property equal to undefined.
Exactly.
The property value is undefined. There's still a property there. When you use the delete operator, that will remove the property. It's kind of weird that you can have a defined property that is, its value is undefined.
That's true. That's a good point. I feel like there's a reason there.
I don't know. I mean, I've actually used that occasionally, that difference, but only once, and I can actually remember it. But because there's also null, right, which is a signal as well. But I think, but can.Map works the same way. Essentially, you can have a defined a map property, which would be in keys, can.Map.keys or whatever.
Mm-hmm.
But the value is undefined.
Yes.
But the property exists. Same way you can do it with JavaScript objects.
Yes. Yep.
Yeah.
And let me see here. Okay. So the only other part, this is actually an extension of one of the slides Justin showed, was composing multiple attributes of a map together. You can do this with the define plugin and computes, which is a lot nicer. For purposes of this exercise, we're just going to use a normal function, and I'm using can.Map extend. So if this looks weird, new can.Map, can.Map extend, what's the difference? Think of it as, if you're familiar with, I'm going to use an object-oriented reference here. If you're familiar with Java or C#, any of these languages, can.Map extend is like defining your own class. This is the definition of something we can create instances of later. New can.Map, we're just creating an instance of it right now. This is what we're creating an instance of. So here, we can do stuff like var p equals new person. We have many instances of this blueprint, if you will, of new objects. Now in our blueprint, what we'd like, excuse me, is for full name to be a function that returns the current first name plus a white space plus the current last name. But first, we need to return something. It's going to be a string. We want to read. We don't want to set anything. We just want to read the current first name. We're going to use the same attr method. We're going to say this.attr first name. This will read the first name. This, because we're in like a class definition, what CanJS is really nice, it's kind of convenient, it lets you do, is the context. This will be set to an instance of person. Just like in a class, this inside the class will always refer to the instance of that class. So this will be this current instance's first name plus a white space, and we'll do the same thing for the last name. This.attr last name. That's all this is going to do here. Then we would like to create an instance of person. var p equals new person. And we would like to give this new person a first name of Justin and a last name of Meyer. I'm going to put that in right here in our constructor. I'm going to say first name will be Justin, last name will be Meyer. Then I'm going to try to invoke our full name function. If I said p.fullname here, this is going to be pointed at this property here. This is defining prototype level or instance level methods and properties. I would like to invoke this, and I expect this function to return a string, which is the first name plus white space plus their last name. And we're going to put the return value in this other div here. So I'm going to say var full name. That's going to be our string. I'm going to say full name text. Full name. We're going to modify the DOM with our new calculated full name. We have 4 nice passing assertions. So this is just a really simple intro to the core basic concepts of observable objects with CanJS. With great power comes great responsibility, and you'll see some more exciting stuff once we get into the define plugin, which is coming up.
Yeah, thanks, Alexis. You know, while I'm about to go to the talk about can.List, it'd be great if you can look up and share my talk that I gave about how the actual internals work of can.Map and can.List.
Oh, okay. Let me see if I can find that.
Yeah, there should be. It should be under either the CanJS Google Plus page or the Bitovi one. Probably the CanJS one, if you look through there. So while Alexis is looking that up, I'm going to go through can.List's API. Alexis, can you see this all right? Just want to share my screen is shared correctly.
Let me switch back.
Okay.
Yeah, this looks good.
Cool. So can.List actually inherits from can.Map. It just has some methods changed around to make it work more array-like. And it has a lot of the normal array methods that you are used to, except that they're made to work observable where appropriate. And you can extend a can.List just like you extended a can.Map, and there's a special static map property which I'll talk about. But let's get into it. So to create a can.Map, you can, one signature is you just pass it an array of items. And here I'm calling this is people, and I'm passing different people names in my can.List. Make sure you have new can.List. And then, so that creates a list of items. I can also pass a list a promise or something like a jQuery deferred, and that will return a can.List of hobbies. But the cool thing about it is hobbies will be initially empty, so you can read the length of a list with * length, and I'll give you the length of that list. But the cool thing here is if I eventually resolve the promise or deferred to include to an array, that list will then take on the items in that array. So it's very common practice that you're loading data from an AJAX request, but you want that data in an observable format to pass to the template now. Well, you can pass essentially a list that will initially be empty, and then when that promise, your data returns, those items will be added, and then live binding with CanJS those items will just show up. So can.List, you can read or write properties just like you do with can.Map. Here I create a list with Alex and Bill. I can change the first item in the list to from Alex to Adam, and then I can read back the first item in the list, and then I can call .atter and get a serialized form of all the names in the list. With can.List, it also works very much like or like normal JavaScript arrays, where if you add an item past the current end of the list, it will fill in any spaces, indexes with undefined. So that's what can.List does too. You can now can.List, just like can.Map, merges properties. So this is going to merge Alice, Bob, and Eve into the list. It's not going to remove anything that would be after Eve, right? This is the default behavior. This is kind of confusing to people, but it's to match the default behavior of can.Map, which is to merge. But like can.Map, if you pass in true, then your resulting map will match whatever array was passed in here. Now, so many people found this confusing that you had to pass in true here. We added a replace method, which essentially does the exact same thing that @true does, but here you could just pass it in your array, and in that case, it'll do a hard replace. A replace can also take a promise. So if you want to, if I had a people list that was Catherine and Eric, and I created a promise and passed the promise, once that promise resolves, so here the promise resolving to an array with Laura in it, well then people immediately update itself to just include Laura. So you can pass promises, you can pass replace promises or arrays. So can.List has all of the normal mutation or reading methods on it that arrays have. So here I've created a list with Lizzie and Abby, and I'm pushing Hank, and I can shift Lizzie off, and I can splice Catherine in. So all of those methods exist. So list, you can listen to events just like you can with can.Map. You can listen to anytime anybody changes the list. So if I were to splice an item, so some new objects into the list, so I have A, B, C here, and at position 1, I want to add X and Y, I will get a change event saying, hey, some change happened at essentially property 1 or index 1. What was happened? Well, things were added. Where it was added, these things were added. So can.List's change event is a little bit different, mostly because with really, if we were to be just like can.Map, we would really just produce a set event at position 1 with X, and then a set event at position 2 with Y, and then an add event at position 3 with B, and an add event at position. But that is not how arrays normally work, so we only produce one change event with the individual mutation. So if you remove items, we'll do a remove event with the items that were removed. So when there is, if you change a property like this, the change event will fire with a set event. It's more similar to how can.Map works. So we changed 0 to A, we'll get the new value and old value. So really, if items are added or removed, we only issue one change event, versus if a property is individually set, then well, sorry, let me rephrase that. With can.List, if multiple items are being added or removed, we only issue one change event with those items that were added or removed. But if you're using the attr to set one value, well, then we just fire a set event with the properties that were added or removed. Again, don't listen to change. Listen instead to list's add method, which is called whenever items were added. Or, so here, if I were to, again, add X and Y at position 1, this would get called back with where they were added and what was added. And there's a remove event that gets called with the same kind of stuff. Finally, you can also listen to a length event, and this gets called whenever items are added or removed into the list. So here, I'm splicing. What I'm going to do is I'm going to remove one item from position 1. And when that happens, the length event will change from 3 to 2, so we'll get a length event. So this is a really convenient way of listening to, like if you want to do something anytime something's changed, well, in the list, you can just listen to the length event. You can also extend a can.List and make helper methods, just like you could on a can.Map. So here I can create a little sum helper function which will sum every item in the list. Basically, sum creates an initial value, goes through every value and adds them up and returns the summed up value. And here I can create a new numbers list and then call sum on it. can.List has a special static map property that defines what type of map instance should be created on any nested object data. So if I wanted to, let's say, create a new person or a new people list, and I wanted every object inside of my array that I'm passing here to be converted from a plain JavaScript object to a person, I could specify that when I'm defining my people list. People, I'm saying the map type to create is type person. That way, and as we saw before when I was talking about can.Map, we added a full name with the define plugin. We added a full name property. This would allow me to do people.attr full name, or sorry, 0.full name. So people, I get my first item in there, but that's converted to a person. So that way I can get the full name. And here, I didn't really talk about it much, but can.Map works really well with like nested properties. So that way, I don't have to write people.attr 0.attr full name. Instead, I can write just 0.full name. Oh, I guess I do talk a little bit about nested properties. So if I have, here I've got a can.Map with, this is for my wife, Pyle, and she changed her last name from Shaw to Meyer. If I have a name property, and then her first and last name, I can listen to on change, and if I changed the last name from Shaw to Meyer, the change event will actually fire with nested, like the nested attribute name. So this is what I'm talking about. Like this is awesome, but also can be slow, because essentially when you listen to the change, not only are you listening on direct properties on that map, you're also listening to any nested properties on that map, or nested objects, nested observables on that map. But it's also cool that you can do that and know when anything changes in that object. So with that, let's have Alexis talk and give his the part for can.List.
Yeah. So can.List, let me share my screen with you. Let me choke for a moment. And I found this video, excuse me, which I'll share in the Gitter chat momentarily. Wow. Okay. So let's scoot this up. You can see it on the screen. So I'm only going to go over basically lists. If you think of maps as observable objects, you can think of lists as observable arrays. Very similar APIs. Lists are going to have a few extra things, like you can listen for a change, like specifically change is a type of event we pass. In this example, we're going to create a new list, a new instance of can.List. And we're going to call it people. Here it is right here. And we're going to listen for whenever people changes. Like Justin just mentioned, and the same reasons we had for person.bind change, you don't necessarily want to do this in your application, but this is a kind of an intro to list. So whenever the array changes, whenever people changes, we're going to place the type of change in this list. But I'm actually going to console log everything that comes out of this. So what I'm going to say is people, which is the instance of our array or our list, find change function. And we want to invoke this function whenever something on the list changes, whenever the list itself changes, I should say. And we're going to push person onto the list after this. But within the change, all I want to do is the list, and I change the text to the type. So when a list changes, we're going to have event, we're going to have the index. Correct me if I'm wrong here, Justin. I'm doing these arguments off the top of my head. We're going to have the type, and those are the ones we care about, actually.
No, it'd be, what do you mean? Yeah, I call that how.
Oh, how. Yeah, that works. There's that here. This will be the actual add, set, remove, change, length. This is going to be what has actually changed in our list.
No, that's the index.
Oh, the third argument is index?
No. It's what it's normally written out as is event attribute that was changed. In this case with can.List, it's typically going to be the index, but it could be 0 dot, full name or whatever.
Mm-hmm.
But it's atter, how, new value, old value.
Yeah, is that not what I said?
Yeah, but I thought you were implying that how is going to list what was changed.
No, it's going to be how it was changed. Add, set, remove, length, or change.
We're on
the same page.
Length.
We're on the same page.
It will never be length.
Oh, it won't be length?
No, it'll only be add, set, or remove. And in the case, as long as you're using.
Let me make sure we didn't have a typo there. Just double checking. The length event.
That's the length event. That's not like a how. Because if you think about when you add or remove things, the length is going to change.
Gotcha. Yep, that makes sense. that makes
So the
sense.
change event, that's like anytime anything changes, is fired, right? But then there's like an add, which is only when things are added. There's a remove, only when things are removed. A length event that you can listen to when things are added or removed. But that's the event type, not the how.
Nope, you're completely correct.
And you won't ever see set unless you're actually doing .at or
0. Yeah. Yep. Very valid. Corrected the typo in this JS bin. And what we're going to do is we're going to push one of these people that we've created previously onto this list. I'm also going to console log the arguments so you can see all the awesome. And we just push P onto this. This is fine. People.push. You'll see a lot of similar array methods on lists to give you a nice shortcut. Push, pop, and a few others, quite a few others. Now, if I run this, we have our changes here, but this is actually what comes through in our handler. So the first argument is our event object. We have a type change, all this good event data here. We have the index, or the attr. Now on arrays, remember arrays in memory, or behind the scenes, we think of them as A, B, C. But in JavaScript, it's more like this. A. I'm not going to write them all out. There's an object that points to a lot of good stuff that arrays prototype gives us. Well, this is pointing to arrays prototype, if it's an array, with things like slice, which is a function, and so on and so forth. So the attribute that's going to come through is going to be this key here. It's going to be 0, 1, 2, and so on and so forth, the actual index within this array. Then we have what actually occurred. This is an add event. We pushed an item that didn't exist previously on this array. So we're going to get type add. We're going to get the new value. This is the new array, the new list. Is that correct? Yeah. And what it was prior, which was undefined. There was no 0 prior. Is that correct there, Justin? That seems...
Yeah, you always get a list of everything that's added.
A list of everything that's added. Thank you. Okay. There we go.
Because you might push multiple things at once. So
yeah, that makes sense.
Push 2 people in with one push statement. It's actually really good from a performance perspective. That way, like if you were adding 20 things to a can.List, live binding doesn't have to like have 20 functions called, and it can instead like create one fragment for every item in that list.
Exactly.
And insert it into the page.
Yep, that makes sense. So think of we're talking about like low level. I'm putting jQuery in here at just a very rudimentary level, just to emphasize these are low level constructs, maps, and lists. Not too low level, but fairly behind the scenes, but really, really powerful when you're building your application. A lot of times we get caught up in like, okay, how does this modify a div? Really, we want to think about this object's property is changing. It modifies anything you need it to. Other objects, calls other functions, etc. And that is the full exercise. I didn't get too deep on lists. Most of it is reflective on maps. And yeah, that's where we are.
Cool. I think I want to show one more thing.
Oh, let me drop this link in for those that are interested. We had a talk, when was this? Back in June, about how, Checo. Oh, nice. I didn't know Gitter was going to pop the YouTube video up like that. about how can.Map works internally, which is really, really good to check out. Nice.
Cool. So just to kind of illustrate better the utility of can.Map and can.List is how useful it becomes when you're, especially if you're stepping outside the bounds of live binding. Now, it's very useful with live binding because can.Stash can listen to observables changing and automatically update the DOM. But sometimes you might want, hey, I've got a canvas clock, and I want that to also use observables, so that if I change my observable doesn't, if it stopped or started, this clock is no longer going to move. So to implement this, I have, is my font big enough? Hopefully it does have, I need to add these semicolons everywhere.
Yeah, it looks good on my screen.
Okay, cool. Let's do this. Oops. Just getting some semicolons so that my IDE looks a little bit better. Okay, so here I've got a timer observable that just has one simple property called time that's set to a date. And I've got a start timer button that essentially is just going to update the time property of my timer to 1,000 milliseconds in the future every 1,000 milliseconds. And then at the end of every 1,000 milliseconds, or sorry, if I hit stop timer, it's gonna stop that interval so the time stops, right? So I have my start and stop button right here wired to these methods that essentially are going to keep updating the time property or stop updating the time property. Now, I want a digital clock and a canvas looking, I don't know what you call it, analog looking clock to represent the time. So what I can do is, Alexis, can you hear that in the background?
Yeah, that's okay.
The baby? Hold on, let me just unplug the baby monitor. Okay, so anyways, what I wanted a digital clock and an analog clock. So the digital clock I could do really easily with live binding. I just have a template here that I have this hours, minutes, seconds helpers that are going to take the timer's time and just get the hours, minutes, and seconds and essentially return those values. And CanJS, its live binding will just take care of whenever the time property changes, automatically updating the page. However, for my analog clock, I don't have live binding, so I have to listen to things manually. But I can with CanJS pretty easily. This is essentially a binding. What you could think of internally, what is essentially going on if I called this instead like the update clock method. Essentially what's happening is it's a shorthand for in init for it to be doing a this dot timer, which is what we pass, dot bind time, and a calling back of update clock so that this is going to be correct. So this dot update clock, and if I was using yes, like 4 or whatever, so I can use the bind method. Essentially, what I had is a shorthand to say, hey, listen to when the timer's time changes and call this back. And I'm going to go back to what that looked like, that shorthand. Essentially, all that's doing is listening to when the timer's time changes, and when it does, it's going to update the canvas accordingly, and there's like helper functions to do that. But this is the nice thing about observables is with CanJS is if the CanJS live binding isn't gonna do it for you. Well, that's okay. You still have observables and can set up your own system around them to update things. So that's how our clock works here. Cool. All right, that's it. We went a little long today, but hopefully it was worth it.
We started a little late. We didn't go too long.
Yeah. Cool. All right. Well, oh, there's a question. Went a little bit long. So that question, let's find that.
Oh yes, it was make traverser. How do we when we do like a meta refactor in the my jQuery?
They didn't see my desktop? Oh, were you seen it? Oh, I forgot that I was clicked on myself.
No. I saw your desktop the whole time. It just switched back right now.
Did. I don't think they did though. Ugh.
Oh really?
Wait for you to be able to notice that. Let me just run through it again real quick. Essentially, I'm just gonna hit the high notes so people can kind of see the code, and I can share it when I'm done with this. But basically, I have that timer map, and for live binding, it's really easy. I just render this little template here with some helpers that read the time property.
Should I be seeing your face or your desktop right now? Because I see your face now.
Oh, you're seeing my face. You should see my desktop. Oh my God. All right. Now, okay.
I see your desktop. Or I see your editor. Yeah.
I'm gonna do this really fast. Okay, we have an observable can.Map to get the digital clock working, which looks like this. That's really easy because all we have to do is let CanJS's live binding, which I render this template and it has these helpers HH, MM, SS, read from the timer's time, and anytime the timer's time is, CanJS knows how to update the DOM, right, with live binding. Okay, that's super easy. But for analog, obviously we can't use, for Canvas, you can't use live binding. So what we need to do is listen to that observable, that timer's time property, changing ourselves, and update the canvas. So that's what this essentially is doing. This is just a shorthand for binding on timer's time property because we passed the timer to our analog widget, or analog canvas widget. So it has the timer, and we're listening to its time, and we're updating what the canvas clock looks like every time the timer's time changes. This is just to show how CanJS, like, you know, its direct observable layer can still be very useful even if you don't have live binding, right? And if you're doing any kind of richness in Canvas, live binding in SVG works. However, do you really want to write SVG directly in a template? Probably not. So you might still build your own, you know, be listening to observables manually to set up live binding with some SVG widgets, D3 or something like that. So, anyways, let's get to that. Let's get to that question that was submitted about what was it? It was the refactoring, how we refactored.
It was a make traverser in my jQuery.
So let's see if we can find. Do we have the? Can we open the? Go to the blog article that you wrote up for this, and then maybe find the result.
Oh yeah, let me bring that up.
Sweet. Russia is watching Siberia is watching our screencast. Awesome. Keep watching. Tell your friends. Okay, you got it?
Siberia, is that what you said?
Yeah. All right. Is this the one with the answer, or?
This is the one with the answer. He was asking how, to understand how we come up with make traverser.
Okay, so this is just one that has it, but not.
This is the one that we created. This was the answer to the exercise. That specifically.
With make traverser, but it has .atter in it. Is failing, which you shared with me.
Yeah, .at. This is the answer to the previous week, but it has next week's.
Okay. All right. Sure. Let's run with it. Okay. So where is the make traverser function? Up towards. Oh, there it is. Okay. So we'll do our best to try to explain how this works if our previous explanation wasn't sufficient. Okay, because this is functions that take functions that produce functions. So it's a lot of functional programming, which might be confusing to anybody who hasn't done a lot of it. So let's try to break this down a little bit and kind of restart. I'm viewing, I'll clone my own live stream. Yes. Okay. So let's start with what's maybe the easiest one, parent, right? And I'm going to implement parent. I'm going to blow up my font here so it's a little easier to see. Let's blow up parent, or let's write parent if we were writing it ourselves without make traverser. Well, what would I need to do? I would want parent had to do parent would take the current elements. If it were doing everything on its own, it would kind of start with like maybe I'd make some parents array, and then I would go through every item in the collection. So I'd do something like each this. Go through every item in the collection, and this would give me each item in the collection's element. And I would add to parents the element's parent element. Or sorry, parent node. And then I would return $parents.
You can use parent element as well.
Hmm?
You can use parent element.
That's true, I assume, in most browsers. But what would the difference between parent element? What things can be a child and not have an element as its parent?
If you have like I don't know if C data has a child. It's stuff like that, where a node will be the direct whatever.
No, I know. I'm just trying to think of something that can actually have a child that isn't a node itself or an element itself. But I'm sure it exists. I just can't think of a time where I've actually seen that. Anyways, let's say we wrote our parent like this, okay? And then let's say our children, if we were to write that out, it's going to look almost the exact same. So this one I have children, and instead I'm gonna use the children to be a little bit easier. But instead, what I'm gonna do is I'm gonna use push, but I'm gonna have to push in each child individually. So I would have to do something like apply, and then make sure I do children. So I'm adding all of the elements children to my children array, and I would do children. Okay, so now what you can see, look at how relatively similar the parent function is and the children function is, right? They look almost the same. There's some kind of accumulator of the elements that are eventually going to be made into the next, into the return result, which is converted to a node list. And then we're looping through every element, and we're essentially from each element, we're getting some other relational nodes based upon that element. So here for parent, the relationship is give me whatever element was in my original collection, and I'm going to give you the parent node. For children, it's give me whatever element is in the original collection, and I'm going to give you its children, and I'm going to add those to the collection. So what all the make traverser is doing is trying to reduce the amount of work, like so that I don't have to write. I just can essentially define the relationship. We go from like what parent looked like is I could just, well, this is parent element, but I prefer parent node just because it's use same APIs and I've never seen in the wild. Anyways, what make traverser does is helping us with, the purpose for make traverser is to reduce the amount of work I have to do. I don't have to do all of this adding to a collection and creating the collection. Instead, I just say, hey, given the element in the collection, return the elements that should belong in the new collection. Okay, so how does make traverser work? Well, what make traverser does is you're passing it that function that represents that relationship. So I'm passing make traverser a function that when called with this being one thing is going to return a bunch of elements that get needed to added to here. So if we look at how make traverser was implemented, hopefully we can see that. Oh, and make traverser itself, yes, it's a function, but it's essentially returning a function that will be some function here. So let's see how that works. So here's the function. This is like, we could, instead of callback, which is probably a terrible name, let's say that this is like get related elements. So that function that we're passing into make traverser is our get related elements function, right? So for parent, this is the get related elements. Okay, so make traverser is going to return a function. Let's say it's returning the, we've passed in, let's say we're dealing with parent right now, parent. So make traverser is going to return the parent function, but we're passing it this get related elements function. So the parent function is going to do a lot of the work that we were doing before. It's going to create that accumulator where we're putting new custom elements, and then it's going to go through every original item in the collection and say, hey, get me the related elements for that. And we're going to forward the arguments, which is just, let's ignore that for now, why we're doing that. But it's just saying, calling this function saying, hey, for the item in the collection, we could have written this out a little bit differently if I wanted. I could have written it the index and the element. I've written element here. Get me the related elements. And then what it does is it just checks. If the result was an array, so if our get related elements return an array, we're going to add that to the elements like we were down below. We're going to add that result to our kind of accumulated elements. Otherwise, if it's just a single item, we're just going to push that in like normal. And then we're going to create that collection at the end. And then the arguments thing here is essentially whatever arguments parent or find all or whatever was called with, we want to pass those to get related elements. And that's so like find all or find can actually get the selector passed to it. So yes, it's definitely confusing because it's like you have to conceptualize what a function is, right? A function is like, hey, do something. So what we're saying is we're passing to one function that does something, another function that does something, and this function combines to write another function that like does something else. I don't know how to describe it better than that. It's just, that's
It's confusing to wrap your head around. Realize, so this is a refactor, and it is a little meta approach, but there's 3 typically very difficult concepts all in one with Make Traverser. You have a function that returns a function. This sounds simple, but if you're getting into JavaScript, especially from like a C# or a Java-based or that type of language, this is a very alien concept, a function that returns a function. On top of that, you have a function that accepts a function as an argument, which is another very alien concept. Simple to say, but it's a little bit more difficult to grasp. And on top of that, we're changing the context within this function. We're manually setting the context with call or apply. In this case, apply. So all 3 together, this is a little difficult, but
yeah, I think the way to think about it though is just like normally people are used to just passing data.
Yes.
But instead, we're making our API, instead of passing data, you're passing something to do. You're passing a method. You're passing a behavior, right? So that's the conceptual leap I think most people need to make, is that not only could you just pass data, but you can actually make part of the API of Make Traverser is you don't pass it data, instead you pass it another behavior. And it generates essentially from your behavior an even bigger behavior. If you think of function or as like an action or something like that.
Yeah, that's exactly right.
Yeah.
In C# you actually call this actions. In C#, I think it was 4.0, they added the same thing, or Java 8 has Lambda functions. So it's starting to come over into different paradigms.
Unfortunately, we need to wrap this up now. If you have further questions about this, come back a week from now and we'll answer them there. This one has run on a little bit too long. So we're gonna wrap it up there. Until next week, I'm Justin Meyer. Thank you, Alexis Abril, and we will see you guys later.
See you guys next week.